Okay, today I'm going to be talking about parallel circuits. Now this one, I've got 4 resistors, and 2 here in series with each other, and 2 here in series with each other. But I made a mistake in my measurements. I'll explain here in a bit. So let's pretend they're all, well, not pretend, but they are all 60 watts light bulbs, and they're hooked up to 120 volts AC, and I measure 44 volts at R1, and R4 is about 28 volts. Whoop, we'll get over here. Hard to focus here. Using the multimeter. Oh, it's a dimmer light, it says there. So R4 is a dimmer light than R1. I don't exactly know why, but probably it has to do with where the hot wire is connected, which is up here. That would be the hot wire. Now BR2 is 35 volts, and BR3 is 120 volts, and I didn't understand why there when I made the measurement. And it's a bright light, what it's supposed to be. Now the current at point A is 0.71 amps, and the voltage at the source is 121 volts, and it uses 86.2 watts. When all together, it should be 60 times 4, would be 240 watts. There's point A there, yeah. Now, I got the 4 light bulbs mixed up. So R3 must be alone, and R1, 2, and 4 are in series. Why they are so dim. And that's what happened, all right. So I redrew it down here. Now you add those voltages up, comes to 107 volts, and it's in parallel with 120 volts. So I can still use, so I just redraw it. And I'll be doing, explaining it proper later in another diagram. So we're just going to work with this for now. So I use a KillaWatt meter, and you'll be able to see that in a related video to measure R2, which is the one in the middle here. Now, just look at these measurements here. BR1, 45 volts, 12.2 watts, 0.26 amps, 10.5. Okay. And down BR3, 121.25 volts, 53.65 watts. And it's using 0.44 amps. Now, what does it say here? Total amps through both branches added equals 0.71, which is the same as the input, I don't know why I added an extra. Oh, that's the average, yeah. Average of the three. And add that to 0.044 equals 0.71. Yeah. Now that right here. The ohms of a 60-watt light bulb is 240 ohms. And the current is 0.50 amps. Now, I think that's why they designed it at 60 watts instead of 50 watts. You know, so it's easier to calculate because it's just 1/2 of an amp. So R1 plus R2 plus R4 in series is 720 ohms. If the voltage equals IR, current times resistance, then the current equals voltage divided by resistance is 120 divided by 720 equals 0.167 amps. But not when you're in parallel with R3, which measures approximately 0.27 amps. Yeah, that's right. Okay, that's enough in those diagrams, but let's look at this other thing here short. I made a bunch of calculations and measurements. Now here I thought I was doing 100 watt, 200 watt light bulbs in parallel. Actually I calculated 100 ohms. But we'll just work with that. So the total resistance of the 200 ohm resistors you go through here, it goes down to 50 ohms. And this here shows 2.4 amps. For 100 ohm resistor, the current is 1.2 amps. And I'll be showing how to measure the voltage drops over those two resistors in parallel. This is something else different here. If you assume the voltage is 30 volts. Okay, so I wrote here, omit, this is for 100 ohms, not 100 watts. Okay. And I'll go through these in another next video. Okay, thanks so much for watching.